Hi, I'm Varun, and today I'll give you a brief walkthrough of the AI agent that I've built. I haven't used any framework like LangChain, LangGraph, or Crew AI. All right, I built this from absolute scratch. These are the features we have currently: React tool calling, reason and acting. Okay, I have added OpenTelemetry tracing for observability. We have access to short-term and long-term memory. Uh, we are managing the context by summarizing the short-term memory, all right, and then passing it to the LLM. We'll talk about it. We have skill support, the agent skills, okay, and then we have MCP server support. All right, now let's get started with the agent, and we'll talk about these features. Okay, I'll just activate the virtual environment. Enter. Okay, we're here. I'm gonna say Python app.py. This will start our process. Okay, the session ID is blank for now. I'm going to press enter. I'm going to press enter again for the user ID so that our process generates a new one for us. All right. It says opening browser for OAuth authentication. Okay, why is this doing this? Because we have added some MCP servers in our MCP config.json. That's why it is gonna approve and authenticate them, and we'll come back to the agent so that we can resume our session. I'll show you what MCP servers we do have right now. We have the GitHub MCP server, Postman, and GitHub. The GitHub MCP server is a local server. These two are remote servers, all right? And both of these use OAuth for authentication. All right, I'll come back here. I'll say what this says. Connected to Get Hired. All right, we have 12 tools from Get Hired server, 41 from Postman, and 26 from GitHub. Okay, the important thing here is that all these tools are not going to be added to the LLM context just yet. All right, whenever we want some tool to be used, only then we are going to load the entire schema of that tool into the context. Right now, only the name and description of these tools are loaded. That is what we call progressive disclosure. Okay, we are going to first check if our local tools are working. Okay, before that I'm going to show you what local tools currently we do have. We have the delete, list, read, and write file tools currently. All right, of course we do have some meta tools for MCP, call MCP tool, get MCP tool, search MCP tool. We do have some meta tools for skills as well. Okay, read skill. Okay, now I'm going to come back here. We're going to say create a new file .txt, and write some random content. This is calling a local tool, write file. Of course, we just saw this, and these are the arguments that the LLM has chosen to pass. All right, this is some random content, and that's the path. The agent says, I have created a file with some random content. Let's just check that. I'm gonna come here. Okay, new file.txt, and we do have some random content here. All right, that's very cool. I'm gonna come back here. That is working. We're gonna check once more. Let's try to overwrite this file. I want you to overwrite this file with some more random content. The agent says, okay, the agent is calling a local tool, write file, and it asks us for confirmation. File new txt, new file.txt already exists. Do you want to overwrite it? Yes, I do want to. This is a harness that I've added so that we do not mistakenly overwrite or delete a file. All right, for that reason, I've added this. I have given a yes, and so yes, the agent has overwritten our file. That's that. This means that we have verified our local tools are working. Now let's move on to testing our MCP tools. Okay, I'm gonna test our get hired MCP server now. I'll just say I want two remote developer jobs. The call should be routed to the get hired MCP server. Okay, it's working very well. Okay, very cool. Calling local tool, search MCP tools. Okay, then we have get MCP tool details, and then we have call MCP tool. This is what the progressive disclosure looks like. All right, we are searching for the tool first. How we are searching that? Because we already do have the name and description for all of the tools from all of the MCP servers that we are connected to. Okay, but what we don't have is the input and output schema. Okay, that's the big deal. We aren't loading the schema into the context just yet. After that, we call the get MCP tool details tool. which will now load the schema into the LLM context, right? After that, we are calling the MCP tool with the necessary arguments, right? The agent says, here are the two remote developer jobs. Okay, we do have something and it looks correct. Okay, this is how we have also verified our MCP server tools. Okay, so we have seen how local tools work, how MCP tools work. Now let's see how skills work. Okay, I'm going to show you a sample skill that I've added here. Okay, we do have two skills here, the React Performance Optimizer and the Superbase Migration Checker. I'm going to open the skill.md. This is how it looks. Even here, we are following the progressive disclosure pattern. Here, if you look, we have the name and description of the skill. Only this gets loaded at the start, all right? We are not loading the entire contents of skill.md, okay? Or even here, inside the references.md, we are not loading all this. We'll load this when we want this. Okay, now let's test this. Okay, so now to test the skills, I'm going to write a prompt. It would be something like this. I need to identify React performance bottlenecks. All right, it should route to the correct skill. Okay, I guess it has. Please provide the React component code you'd like to analyze. Okay, I don't have the code at the moment. Just give me the guidelines. Try once again. I don't see them. Okay, so now the agent has provided the guidelines. All right, very cool. This means that the agent is successfully able to identify the correct skill and read the skill.md, even the md files inside references. All right, that's that. Now we have also verified that our skills do work. Okay, now let's just talk about what short-term memory is. The short-term memory is nothing but just the conversation history that we pass to the agent on each model call. All right, we got to pass it something so that it remembers what we have done, what we like, we do, what we don't. All right, but currently the short-term memory is tied to the in-memory store. This means that whenever you close your session, the in-memory store is gonna wipe out your session memory. All right, this means that even when you're using the same session ID to start a new session, you won't be able to see your previous conversation history. To do that, we need to extend the in-memory store to support, I'd say, a database. We gotta persist the conversation history somewhere, and for that we can use SQLite, Postgres, whatever you want to choose, and it is easily extendable. Currently, we are just using in-memory store, but of course, in future we'll extend it to multiple stores. Okay. After that, let's talk about the long-term memory. What's that? Long-term memory consists of three things: the episodic, the procedural, and the semantic memory. All right, let's test it out. We are using a method similar to what mem0 does use to store and retrieve long-term memories. Okay, now let's try and let's check if it works or not. I'm gonna say my name is Varun and my favorite color is black. I'm gonna press enter. Nothing's gonna happen for now, but when I close this session, we usually save our long-term memories at the session closure. All right, I'm gonna close this, and then after that we are gonna use the same user ID to restart a new session, and I'm gonna ask the agent if you remember my name and my favorite color. You can also see here it says we are now saving your long-term memory. Okay, fact saved in long-term memory. Key is name, value is Varun. All right, fact saved in long-term memory. Key is favorite color and value is black. Oh, very well. I'm gonna again start the session. Python app.py. It will ask for my session ID, which I'm gonna leave blank for now. I'm gonna pick the user ID from here. I'm gonna paste it here. All right. Okay. What's my name? Your name is Varun. What's my favorite color? And it should answer black. Very well. The agent remembers us. All right. If you enter the same user ID, the agent is gonna remember you. But now guess what? My name has been updated. All right. I don't want my name to be Varun. I want my name to be. My new name is Varun Kumawat. and my favorite color is red. I've updated both these information, so I'm gonna press enter. As expected, nothing will happen now. When I press exit, it is now going to save the long-term memory. It will update the existing memories to conform to whatever we have added in this session. Okay. It says we are saving your long-term memory. It also says fact saved in long-term memory. Operation is update. Key is name. Value is Varun Kumawat. All right. Again, fact saved in long-term memory. Operation update. Key is favorite color. Value is red. I'm gonna start a new session once again with the same user ID. You see this because I have emptied the mcp-config.json. This is not an error, all right. Okay, back to our long-term memory testing. Okay, I'm gonna ask it, what's my name and my favorite color? The answer should be Varun Kumawat and red, not black. Okay, that's something important. Very well. Your name is Varun Kumawat and your favorite color is red. So we now know that our long-term memory is working. All right. Okay, then what do we have? Okay, we have observability. We are using OpenTelemetry for that. Okay, um, I'm using Jagger to export my OTLP traces too. I'll show you the dashboard. All right. Okay, this is my dashboard, the Jagger UI. Okay, this is my service, my agent. I'm gonna zoom in a bit. I'm gonna open one of my turns, say this one. Okay, there's some issue here with the CSS files. I don't know what, but I'm gonna just select everything so that you're able to see something. Okay, just a sec, give me a sec. Okay, I've selected everything and you can see the trace starts here. My agent turn, this is the start of the trace. Then we have one iteration and one model call. So these traces and the spans give you all the information that you want to have. All right, it says we have this tag, the outcome is success, this is our session ID, this is our turn ID, all right, and all of that stuff. After that, we have an iteration span, below which we have a model call span. Here it also says that we have provided this system instruction to the model. You are a general purpose personal assistant, whatever, okay, and all of that stuff. That's that. Okay, okay, we have some more, you know. I'm gonna select it once again. All right, all right. Very similar. You'll see all of that stuff. Okay, whatever you want to inspect and observe our agent, you'll find it here. I have given the command that you'll have to run to start this UI. Okay, you gotta export your traces somewhere. I'm using this. You could also use Datadog, maybe Signals, right? Whatever. But to use what I'm using, you'll have to run this command. You'll have to have Docker setup. Okay, that's that. And of course, the code is open source. You can go through the entire code, not an issue. Okay, we discussed how local tool calling works, how tracing works, short-term, long-term memory, scale support, MCP server support, and okay, the context management. This is very simple. Whenever we reach say 80% of the model's context window, we are gonna cut short the short-term memory. Okay, we're gonna summarize the previous messages and we are gonna add maybe that summary to the system instruction. This is what we are doing currently. This is how you keep the context in check. All right, and that's that. Really simple. Um, that's what it is. But in the future scope, of course, we discussed that we gotta add a persistent memory store. All right, that's one thing. We are also gonna add the sub agents feature. Okay, in which way our main agent would be able to spawn sub agents. I have a design ready for that. That would be implemented soon. That's that, and of course some other things as well. I have written a blog on this. I'll leave a link. You can check that out as well. All right. Thank you. Take care.